I am Jim Wenderlich. I'm a principal architect that is the lead architect on the Salesforce DX project. On my left here is Mike Miller, who leads our source-driven development team. We are both engineers, so you are not going to get a product talk here. There is a session right after this in this same room by John Vogt, and he will take you through the whole product if you haven't seen it. We don't have time to talk about everything, so it's a very broad project. I have to do this. There will be a test at the end. I have to say much because you've all seen this 100 times by now. This is actually very forward statements. Hopefully some of you have seen some of this, maybe in the partner keynote, some of the other sessions where you're starting to see some of the things that we're doing in the development experience. But the entire project actually has a huge footprint in Salesforce. There are at least 3 dedicated teams. There's probably another dozen teams that are helping us with different parts. This is just a short list of everything kind of categorized in the ALM lifecycle, right? Where you develop, you test, you deploy, you feedback. I didn't create the ALM cycle. I'm just using it to illuminate here. So we can't talk about all these things because we'd be here for hours. We are going to drill down on a couple of things here, scratch org, source syncing, and the CLI. We're going to mostly do it in command line. So if you're here for pretty pictures, hopefully you think a command line is a pretty picture. I wanted to point out that when we do architecture, we do engineering, we do product design, everything we do at Salesforce, we do it with some values. Mark talks about this a lot. But we do this all the way down to our actual engineering practices. That we don't have conversations about architecture without knowing what we're actually trying to bring forth. And we call them coders in this. It was kind of cute. That was actually a product guy that came up with that. But the one I wanted to point out with this is open. That everything that we're building is enabling you to build your own developer experience. I have been a developer for a very long time. I won't say how many years. And what you can't do to developers is tell them how to develop. They really get mad. So this is all about bringing tools and a process and opening up your ability to do development like you want to do. That's the entire goal. I mean, we have some of these other things that are important here, like open source and that kind of thing, which are important. But the number one key element for us is open. I can do this, right? So development today. A lot of people use a sandbox org. They got 3 people all developing in the same sandbox. One person elects themselves and often goes over to the metadata retrieve and pulls out the source. We didn't invent what we call source-driven development. What we're trying to do is make it easy to do. So Cody the Bear up there is up in frustration because he has to figure out which source to pull out of the org. There are people like Cloud9 and some other tool vendors that have tried to automate this, but they quickly run into scaling problems or just a dead end. Some of you have maybe moved on to this model where everyone has their own org. So each developer works on their own org. Everybody pulls out their own source using metadata retrieve. There may even be you might have automated some tools. But what we're trying to do is bring a slightly different model that merges this all together and enables people to do it. We're introducing scratch orgs, that every developer uses their own scratch org. We are actually making it problematic to actually have 2 people using the same scratch org. It won't work very well. You may actually collide. And what we're shifting the development to is into source. And so one of the fundamental shifts that we're making is shifting to the source of truth, is what we call, instead of being in the org, starts in your VCS. Now, we're going to demonstrate GitHub because of all the people that uses VCS in here, how many people are using Git? How many people use something other than Git? All right, we're Salesforce, we have to use Perforce ourselves. So I feel, unfortunately, when everyone demos source control now, they use Git. And that's what we'll do today. The source of truth means that you can define everything in your development, including configurations, CI processes, everything in source. So the org becomes a container to run code in. It's analogous to the JVM. If anyone who knows Java in this room, you compile it. It compiles into something that is completely worthless. The machine does not know how to execute it. And you stick it into a JVM, and then it executes. Scratch orgs are the JVM of Salesforce. They're a little bigger and a little heavier, but that's what the role they play. You have source, you stick it in the container, it will run. And we do that by introducing a new thing called a scratch org. Now, why did we have to create scratch orgs? We often say it's not another DE org. Almost probably everybody, how many people know what DE orgs are? And they use them pretty regularly, right? We took the best things from DE orgs. We took the best things about branch orgs. Is anybody using branch orgs, the pilot in the branch orgs? Which is about namespacing. But most importantly, if you look at how Salesforce internally does their development, we open up an org, we use it, and we throw it away. One of the founding principles of our work is that if it's good enough for Salesforce, it should be good enough for all you. And the idea that you have to stick things in orgs and then try to uninstall them, how many people have uninstalled scripts or try to uninstall things from orgs? It's problematic, isn't it? Eventually, the org degrades and you have to throw it away. And it's a silly thing. In fact, if you look at our CPU usage, people spend more time uninstalling than installing when they use source-driven development. So it's in our best interest also to help you with this. But the whole idea is you would use an org, when you're done with it, or if it degrades or it's broken, you throw it away. And so that's one of the things. Next thing is global namespace, the branch orgs I mentioned to you. People that develop managed packages, the ISVs, they want to work with an org that has their namespace. Right now they have to go into a release org. Real pain in the butt when you have 3 people. You don't want them all in the release org, so you have to pretend you're not in a release org, and don't make a mistake now. God forbid that you reference something by global namespace, it won't work. So we want to be able to support everyone having a global namespace in their org. Org shape, ISVs, how many are ISVs in here? ISVs have a particular problem, and that is that they have to support a whole lot of different customers that have what we call different org shapes. You might have heard the term before in different ways. Org shape is each customer's unique view of the cloud. It is our secret sauce, in fact. It is the thing that we hold most of the patents on. And the idea is that you may have this entity. More importantly, you may have a column. You may have a feature. If you don't have Service Cloud licenses, you will not see Service Cloud entities. Hard to write code to do that. But it's even harder to test it. Because if you want multi-currency, you have to call up and call customer support right now just so that you can test. Or you can do development. Because they have to turn it on for you. And then now you're stuck with that org, and you're going to be stuck uninstalling it. So the other thing is what we want to be able to do org shape by declaration in the development cycle. Push topics, we're just going to demonstrate that, I won't go into that. And then having to be able to have a controlled environment, licenses and that kind of thing. So that was a little less magnified. So that is the reason why we built scratch orgs. So we're going to do a little demonstration about what they are. Mike here is going to do the demo while I talk, at least in this section. He is, first of all, going to show how, so we're going to geek out a little bit because one of the goals of this was to show some of you how what we did to make this work and behind the scenes. Mike here is showing a page here that is listening for a sign up. So this is kind of like the going forward model that instead of having to poll all the time, you listen for events. This is actually happening across all the Salesforce. And then you will know when a scratch org gets created. So here he has a little JavaScript that's listening to a subscribed topic. And now he is going to create a scratch org, that's what they are. A scratch org with a configuration file. He opened, oh, that's right, great. And now he's going to create one. And the configuration file that's listed there, we're going to show it to you in a second. Oh, I'm sorry, yes, we're going back. Sorry. The listener, you can see these events that are happening. The command line, which we're going to talk about extensively in a few minutes, notices the org is created, and it says, look how fast that org got created. Now that org is ready for you to use. It's empty. Especially when you see it for real, it will be very empty. We're not going to have accounts in it and all this other stuff that people don't understand why we have it in a development org. You're going to show the command line, the config? Do a cat. Hit. Yeah, it's getting a little low for some people, huh? Okay, sorry about that. So this is a configuration file. You notice it's JSON. It is part of your repo. And this particular one is, says, I want an org with chatter off. I have a customer that has no chatter turned off. I need to make sure my code works. So a more interesting demonstration, though, is that we can query for multi-currency. This is a very common thing in code, in Apex, if you've ever worked with multi-currency. In Apex, you have to query, and you often have to query the currency ISO code. This is a great example of org shape. That field doesn't exist in the Scratch org we just created because multi-currency didn't get turned on. Now, if we create one, you want to cat it first? You're just going to create it?
I'm just going to cat it.
Okay. If you notice here, we say, oh, this is a different configuration file. We are turning chatter off, and we're turning multi-currency on. Right now, you have to call customer support for that. So now he's going to create that. You notice we're using a lot of our command line because everything we're building is in our command line. So this is what I said, we're going to be a lot of green screen here today. Now when he does this query, lo and behold, it's there. That is what org shape is all about. This is what Scratch orgs. You notice how both of those got created pretty darn quick. The idea is you can create them quick, use them quickly, and get rid of them. And in fact, we're going to delete one right now. We're going to delete our first one. One of the things about Scratch orgs, though, is that you have to clean them up. You have to delete them. We are not going to delete them for you. Well, not exactly true, but we might do it just to keep everyone honest because we don't want people building Salesforce production databases, production orgs using Scratch orgs, as you can quite imagine why. So we tell people we can take them away at any time because remember, they're supposed to be coming from your source of truth, not from an org. But when we finally get it licensed, we will say you can have X number of active orgs. If you don't delete them, we will say, I'm sorry, we're not going to create any more for you. So the idea is that you have to clean up your own trail of Scratch orgs. This is all done in an environment hub, so there is actually a UI that can help you with this. All right. That's pretty good on the time. All right, Mike is now going to talk about source sync and how we do source syncing.
Coming back to...
Hit the button. Didn't work?
Do we have to hit the, yeah, sorry. Maybe. So source change tracking. Why do we need source change tracking? Salesforce is a unique development environment in that different types of source are best edited in different locations. Things like Apex classes, you may want to use your favorite IDE, your favorite text editor, things like that to edit on your local workspace. More complex objects like a Lightning app or a process, you want to take advantage of the rich in-org builders that are available. Salesforce DX enables us to use the best tool to do the job that we need to do. And to enable that, source change tracking needs to be able to make sure that the metadata on your file system is in sync with your Scratch org. And rather than constantly doing a deploy of all the metadata or a retrieve of all the metadata, who here does that today? Where it's just a full in and out using a package.xml. With source change tracking, what we do is we actually monitor the changes being made to the source, both on the file system and in the Scratch org, and only push or pull those items which have changed. How do we do this? On the local file system, we keep an index of all the files in the workspace. And for each file, we keep a set of attributes. We keep things like the file size, timestamps. We keep a hash code of the contents of the file. Every time we push the source to a Scratch org, we take a look at that index and we use that information. We compare what we've recorded with the current state of the file. Anything that has been modified gets sent to the Scratch org. For the in-org tracking, we've actually introduced a new tooling APIS object called source metadata member. When edits are made primarily through the builders or through the setup menus in the org, we ensure that a record is created in the source metadata member object, and every change gets a continually increasing revision number. When we pull the source, we keep track of what the maximum revision number is we got out of that scratch org. And then we can use that revision number the next time we query the org to find out what has changed and to bring down just those changes to our local workspace. All of this is independent of any particular VCS. It's the Salesforce DX tooling that is managing all of these changes and tracking all of these changes. So you can use Git, you can use Perforce, you can use Subversion, whatever tools you want to use, the Salesforce DX tools sit on top of that and allow you to efficiently move those changes between your scratch org and your workspace. So let's take a look at source syncing.
And we're back to our friends.
So now we're back to our CLI. The scratch org we just created is an empty scratch org, as Jim mentioned. So there's nothing, we have no metadata in it right now. Additionally, we've started to we're starting to evolve the source format that we're storing in workspace. Yeah, you can see no Apex classes in there. In the workspace, we're breaking some of the rules that have existed. Like the metadata API forces you into a particular directory structure. Logically, you often want to separate out your test classes from your regular production classes just to make it easier for developers. So you can actually move your metadata between directories now with Salesforce DX. Another thing we're exploring is breaking down complex objects like a custom object. A custom object is a huge file, right? And if you've got a team of developers all working on the same object, often you end up with collisions, right, that you have to resolve. What we're doing here is we've broken it down, all of the subparts, the fields, the validation rules, the compact layouts, all of those pieces are being broken out into their own metadata, which can be managed and synchronized independently. Change one field, only that field gets sent to your org. So Jim is doing a push of our source. The first time, because our org is empty, the first time the push happens, all of the source in the workspace is identified as new and is pushed into the scratch org. Subsequently, when we do a push, we'll see that no changes are identified at that point. Here we can see, you can also see in this list of source that was pushed, it's now got the namespace on it. We're applying the namespace to the source as we deploy it into the scratch org. The scratch org has the namespace. You can develop with your namespace. You don't have to wait till a release org to utilize the namespace. You can do that development right now in the scratch org. So,
oops, sorry. Hit the wrong one.
That's coming up later. So we've got a test that is failing here. And what we want to do is we want to make a change to the class that is causing this test to fail. And we'll make it on the local workspace, right? We'll use Jim loves VI. Like he said, he's been developing for a long time. So we're going to go in, and in this case, this is failing because our code is not checking to see if chatter's enabled. And as you may remember, the org shape that we've defined is a chatter disabled org shape. So our test is failing. So we're going to go ahead and add a check for that, save it, and we'll do a push again.
Yeah, sure.
And Jim has two N's enabled.
There you go. You see, now this is, now you can,
So we'll pair program with Jim.
Too bad we didn't do
in
this
a
yet. Yeah,
massive,
there we go.
massively pair programming modality here.
this is where IDEs are very helpful.
Yes. Now you can see that only that Apex class was identified as changed and submitted to the Scratch org. We run the test again, and we see that it's now passing. So now, let's go in, let's take a look at that same class in our Scratch org. We'll refresh. Yeah, we haven't come back to our Scratch org to see that all of our metadata is now loaded into this Scratch org. We're showing classes, but everything, custom objects, Lightning components, all of that has been deployed. So let's just, now that we know this is working, let's just go ahead and add a comment for the future so that whoever comes along next doesn't make the same mistake. We'll go ahead and save that. And now we'll go back to our CLI, because that change only exists in that Scratch org. Again, the Scratch org's temporary. It can disappear. We're going to do our pull, source pull.
But that. It doesn't
We
get
renamed
changed.
some of our commands through the development cycle. And so again, you can see now that we've only pulled that one class that was modified. So how do we do this? Let's take a look at, we can run a query against source metadata member for everything that's got revision number greater than 1. So here we can see once that metadata was updated, the metadata, the source metadata member row was created. Now, our local source has 1 as the maximum revision. So when we query in the future, only revisions greater than 1 will be retrieved. On the local file system, let's take a look at that index. The index is stored as a JSON file. We're not going to go through the whole thing because it indexes the entire workspace. But again, you can kind of see here, we've got times and dates and the content hash. A lot of times, you may be aware you touch a file, the date changes. That's not really a change anybody cares about, right? So if we detect that a date has changed, that a size has changed, we immediately compare we then fall back and check the hash of the contents to identify whether this is really a change we care about or not. And either way, we update the index and save it back out. So that was source syncing in a nutshell. Throughout our demos so far, you've noticed, and as Jim mentioned, this is all being done via a CLI. The CLI is the piece that does the heavy lifting for the Salesforce DX project. It's an adapter, so it takes existing public APIs, maybe a couple of new ones, and stitches them together in a way that automates common development tasks. It takes those public APIs and exposes them in usable ways. The CLI, we've chosen to implement it on the Heroku pluggable CLI architecture. To do that, it's implemented in Node.js. Anybody can develop plugins for the Heroku CLI. There's a few rules you have to follow, and then it'll pick it up and run with it. The CLI is universal. We've been looking at it within the workflow of a developer and how a developer might utilize it. But it can be embedded into IDEs. It can be integrated and scripted into CI systems. It can be utilized in all sorts of different manners. It gives you that consistent API to those common developer tasks. And lastly, the CLI provides a common authentication mechanism. It uses the web and JWT bearer token OAuth flows to authorize the user into the environment hub so that you can create Scratch orgs. And then during the creation of the Scratch org, it also does that authentication. So once a developer starts up with a workspace, they authenticate once. That authentication is carried through all future commands until they need to use a different environment hub at this point. So let's take a look at the CLI. So here we're taking a look at the Heroku CLI. We have two plugins right now. We have the Force CLI and we have the Salesforce ALM Dev. The Force CLI is the, you may have used the Force CLI Heroku tools in the past. We've taken those and we've integrated them in with the new Salesforce DX commands. The Salesforce ALM is the new commands, the push, the pull, the create a Scratch org. All of that are the ALM commands. The Force CLI gives us the familiar commands like sockle query or creating DML, things like that. So now, actually, let's switch back to our org a second. We've been working on the Dreamhouse app. And let's go to our app launcher. And we want to test it. I want to manually test it, but you can imagine this is also part of a CI flow. But our app isn't showing up. So our app is controlled by a perm set. Without the perms being assigned for our user, nothing's going to happen. So we've added a new command that allows you to assign a perm set to the user. Now that we've done that, voila, there. Our app appears, and we're able to go into it. Now, the app is interesting and all, but we have no data. And again, especially in a testing environment, running it through automated testing, you're going to want canned data. You're going to want that set up part of your source that your developers can use to test and your CI systems can use to test. So we've also added a command to load data into the Scratch org. So here again, you can see we've now added a bunch of data, and voila, the app is ready for testing. So we've been looking at the CLI from using it from a shell. Let's take a look at this is the new Force.com IDE that's being demoed in the Salesforce DX booth. You may have seen it in the keynotes. You can see that we have the same CLI commands available from within the IDE. You can do all of your development within the IDE, should you choose. You can see we've got our XML here for a Lightning app. But that app, as I mentioned, it's better to make changes using the Lightning app builder. So within the IDE, we can actually launch the builder, add a component to the page, and you can see on the bottom there's a polling going on. It's polling for changes right now. In the future, we're going to have a push topic available that you can listen on so that you'll get an event when that metadata has been updated rather than having to poll. But in this case, we've been polling, and you can now see that it went ahead and did the poll. It's the same CLI command, and it's updated our source ready for check-in. Let's also take a look at CI. We've got a Jenkins here that's using a couple of interesting features of our CLI. We've got a chatter on and a chatter off org shape now. We've been bitten by that bug. Let's test against it. So we'll run a test run with each of those configurations. We're using the same CLI, again, integrated into Jenkins to do our org creation, to push the source, to load the sample data, assign the perm sets, to run the tests, all being executed through the same CLI. And with that, I would like to hand it back to Jim to talk about the future.
Yes, where would we be without a future? So, like I said, the Salesforce DX, big footprint. We're only here to talk about these three things. So it's not a full roadmap. That's you'll hear that in some other sessions. But I did want to point out a couple of things from the things that we did talk about. The CLI, we have every intention of making it open source, which is actually intended to be a community tool. We hope all of you contribute to it. We will continue to contribute to it. It is basically trying to take everyone's best practice. We didn't invent some of this stuff. We just encapsulated it in this new framework. And we hope to bring other tools in. And we have a kind of a separation between what we call plumbing and porcelain commands from Nick Chin. I don't know if he's in the room. And there's ideas that we have these really low, fine grain, granular commands that you could be able to build up into more complicated things that would do, like we have a very advanced test runner, but it actually calls other parts of the command line. In source change, you've noticed that we were polling. By the time, hopefully, that you will see this, we will have it listening, and so that we will push metadata changes to you. So you will not have to poll. You can sit there and have a listener and actually maybe keep a source repo up to date automatically for yourself. We will be building that into the command line, but it will be a push and it won't be doing API calls and all that. And then the more interesting thing is that we're trying to push people into doing the development and CI, because we have sandboxes. Sandboxes are great for user acceptance testing, for training, for testing package installs that aren't yours. Like there's a reason why we have sandboxes. For development and CI, since we want repeatable orgs with certain shapes and have certain outcomes, we don't want the variability necessarily that you get in sandboxes. And so we want to push everyone toward isolated boxes, isolated orgs, that you literally aren't relying on anything outside that org to do all your development and testing. Now, we're going to let you put packages into that Scratch org. We're going to have all that dependency and everything. That's some other people talking about that. But when we get to that point, then we could actually get to a point where we could pick an org up and put it in a VM. So we have lots of plans about where we're going to put these Scratch orgs. What's important for you guys to know is that as soon as you get your development process into that isolated org, we're going to be doing all kinds of exciting things that are really going to speed up a lot of things and make it really fast. So we're really looking forward to that. We have to get some process stuff in place first, and this is starting out with the command line. You start using it, and we will give this stuff to you for free. So wrong word, not free. Not my decision, that's engineering. It's definitely not engineering's responsibility. So, okay, we've got 7.5 minutes if there's any questions.
There's a microphone in
There's a microphone, yes, that we're going to ask you to. I can't pace as much as I'd like to because apparently there's a camera. So, anybody?
This is being, sure.
Okay. Would one of the product guys like to answer that question? We are doing some dev preview toward the end of this year. You need to contact the PMs for that. And we will start rolling it out next year.
When you say VM, are you talking VM on my local machine?
No. So since we're engineers, we can be honest with you. There's no way for us to protect our code. Unfortunately, Java, we're primarily a Java core stack. We can't protect our code, and that would open up a threat vector that you would find intolerable, or at least your legal department would. Like, what do you mean someone could decompile our entire core stack? That would not be a wise. So that's why we're moving toward this other thing. So if we spin it up in a VM in AWS, then we would be controlling it, but you would still get the benefit of having an isolated environment so that you could like debugging full time or something like that.
DX is built using Node.js. Does the developer need to learn Node.js to be able to do that?
No. The tool is built in Node.js, but as you saw, all the command line is exposed in a friendly way. If you wanted to participate in the open source project, once that happens, then you would need to learn Node.js. But there's no shift to Node as part of
If you want to write a command, you have to learn Node. though.
Yes.
But to use it, absolutely.
Yeah.
Configuration files and for everything that
Yep.
you don't use.
Right.
Yep, it just, you do JSON and you script your
You do have to learn JSON.
Yeah,
Yeah,
you do.
but there's a,
When you pull down metadata, you also pull down profile information associated with it.
profiles. Gosh, we almost made it out of here without asking someone else.
oh
about
gee, look
profiles.
at the time.
So we have to change the way profiles work. And so stay tuned for some exciting changes coming your way. How's that sound? And that's all I can really say. I mean, we are going to change we are going to expand perm sets. We are going to make them work. We are going to give you a path to make this all rational. So part of Salesforce DX is fixing some of our real problematic areas of development. And you happen to hit on one of them. So. But there's no magic button. I mean, there's no magic whatever.
Right.
Yes, unfortunately.
Yeah, that configuration JSON file, there's so many switches that it looks like you're going to have in there. Are you going to have some kind of tool for
Yeah, so we don't have it in the IDE right now, but the IDE will have autocomplete and will help you in creating those configuration files. And then we're also looking into different JSON schema tools that we can use to also help you with that.
Will you be able to just export a production works configuration file?
No. So one of the ideas is to extract org shape into a configuration file for you, but we want to purposely not let you copy stuff directly from production into a scratch org. So we're doing that on purpose so that everything comes through source, remember? So
Yeah, well, if you wanted to create a scratch org that loosely looks like your current production org, that's
yeah. Yes. Okay.
Metadata that is not exposed today, like email to case settings and other data that we cannot push using code.com ID to GitHub, would that be exposed as well?
We will make progress in that area. So she asked about metadata that we don't export right now. This is a multi-year project. It's keeping me employed. And we will be addressing that. Yes, we call it metadata completeness.
Is the IDE that you showed going to be kind of mandatory to do all this? It looks like it's Eclipse-y.
It is Eclipse.
Yeah,
It's not Eclipse-y, it's Eclipse.
it's not mandatory. It's just the reference implementation for integrating the CLI into an IDE. We've chosen to move our existing Force.com IDE forward, which is an Eclipse-based IDE. But the idea is that anybody could, partners or whomever can integrate the CLI. One of the developers on our team has gone through a process and he integrated it into Visual Studio and I can't remember, a couple
And
other.
then, it was awesome.
Yeah, Nick, who if you go by the Salesforce DX booth, he's probably there.
Right back there.
For orgs with lots of security and complex data requirements for testing, is there a limit around the amount of data you can import into a scratch org?
We're working on those details. That's a tough question to answer without a lot more background. We intend to be able to release some of the security stuff to be very declarative. But as far as how much space you would have to have, we're going to be able to, we have some flexibility, let's put it that way. But out of the box, if you have a really heavy thing, you might have to ask for permission, yes. So,
Do we need any Heroku account
No,
to do that? Or
No.
only client side?
yeah, just
but Heroku is a fabulous product, though. So you should have an Heroku account.
But it's not required.
It is not required. If you want to run the Heroku commands, which is in the same tool belt, yes, you would have.
So again, the CLI is creating a unified development environment for Salesforce, right? Heroku and Forces.com.
Okay, we got time for one more.
How would it handle the integration conflicts when three developers are working on the same file and they're trying to take it to scratch up? How will it handle the integration conflicts?
Okay, so we don't have to do conflict resolution in orgs because remember the first thing I said, you're the only one in it. You can't have a conflict because you would have a conflict with yourself. How do you resolve it in the source side? this is why we're making source, and we're going to make the source look better, it's going to merge better, is that we are relying on the VCS to resolve those conflicts. So you will go through and get, like, Perforce, it's a lot easier, by the way, to resolve conflicts. But if the source systems will detect that conflict and help you resolve it. So this is a much more modern development way of traditional, Java, Python, Node, that. Where over time, we're going to be building tools on top of that that hide that for people that want to do more declarative type programming, more of the Power Admin or anything like that's supported today. But this first rev is really just the command line. You really got to use the tools that you have that already do that. Okay, we're out of time. Thank you very much for coming.